In this video, I'm going to solve some exercises about greatest common factor and least common multiple. Here I have asked two questions, and I asked greatest common factor and least common multiple of them. And one of the most important part for me, I'm not going to do two different operations for greatest common factor and least common multiple. When I'm finding the greatest common factor, actually I'm finding the least common multiple. This part is important for me. So 14 and 21, I'm going to write them here. Then I'm going to start to divide them. And 2, we are starting with 2. You know the smallest prime number is 2, then 3, then 5, then 7, then it's going to continue like this. Then when you divide by 2, 14 is only divisible by 2. When you divide by 2, the result is 7. 21 is not divisible. It's written same again down. And now another prime is 3. And we are dividing by 3, but 7 it is not possible. And 21 divided by 3, it's 7. The last one it's going to be, there is no need to try 5 because we know that 7 is not divisible by 5. And that's why we are going to use directly 7, and 7 divides both of them. So I'm going to circle the 7. So here I'm going to write like this: greatest common factor of 14 and 21 is 7. Actually, if I do the least common multiple here, I'm not going to circle anything, and I'm going to find the same results. Here, actually, when you divide by 7, I forgot it's going to be both of them, they are going to be 1. I forgot that one. Sorry for that mistake. Then let's return to least common multiple part. Least common multiple of 14 and 21, it's going to be multiplication all of these numbers. So 2 times 3 times 7, which is equal to 6 times 7, which is equal to 42 of 14 and 21. Okay, the second exercise, this was the first exercise. The second exercise is 30, 40, and 20. The written order is not important. You are starting from the smallest one or the greatest one. That's not important actually. And here I couldn't draw the line, but at the end it's our line. Then I'm going to start with 2 because it's the smallest prime number, and actually I'm going to get in circle because 2 divides all of them. Here it's divided 15. Here it's divided 15, here it's divided 20, here it's divided 10. So 2 in circle. Now there are some numbers divisible by 2. That's why I'm going to continue with 2. Here 15 it stays same. Then 20 divided by 2 it's 10. 10 divided by 2 it's going to be equal to 5. And as I see, there is again number divisible by 2. That's why I have to continue with 2. Then it's going to be 15. Then this is going to be 5. And this is going to be 5 again. Here, none of the number is divisible by 2. Then I'm checking by 3. Is there a number divisible by 3? Yes, 15 is divisible by 3. That's why I'm dividing by 3. But this 3 is dividing only 15. That's why I cannot get in circle. So 5, 5, and 5 it's going to be. And the last prime here is going to be 5. And it divides all 3 numbers. So that should be in circle. And the results are going to be 1 and 1 and 1. So the greatest common factor of these numbers, which are 30, 40, and 20, are the numbers which are circled 2 times 5, which is 10, and least common multiple of these numbers 30, 40, and 20. There's no need to do another calculation for that one because we are going to find these numbers again without circle. So it's equal to 2 times 2 times 2 times 3 times 5, which is equal to 2 to the power of 3 times 3 times 5 it's going to be. And we know this one, it is 8 times 5, it's going to be equal to, and 8 times 5, yes, it's equal to 40, and 40 times 3, it's going to be equal to 120. So the answer is 120. Least common multiple of 30, 40, and 20 is 120 is going to be. Okay. This type of questions, word problems about the greatest common factor and least common multiple. We are going to try to analyze the question, and we are going to try to understand which one we are going to use, least common multiple or greatest common factor. Here a man has a rectangular field, and here I'm going to draw one rectangular field, and it says that one side is 250 meter long, so it means that the longer side is 250, it's going to be 250 meter, and the smaller side is 160 meter, it's going to be. Then he wants to put trees around the field so that the distance between each tree is the same. Find the least number of trees that the man needs and distance between them. So we are going to find the distance between each tree and how many tree we need for this field, and we are looking for the a number is divisible by 250 and 160. So the number, when we divide here, I want to show some examples. Let's say the distance between them, they are going to be equal here, and here also on this side they are going to be equal. So we are going to find the greatest number which divides both of them. So dividing means it must be the factor, it must be the greatest value, and it must be the factor because it must divide both of them. So greatest common factor of 250 and 160 we should find firstly. So 250 and 160, when we find the greatest common factor, you know this operation. We are going to do prime factorization for both of them now. 2 divides both of them, so I'm going to circle 2, and this is going to be 125, this is going to be 80. One of the number is divisible by 2 again, that's why I'm going to continue with 2. 125, 40, divide by 2, 125, 20, divide by 2, 125, 10, divide by 2, 125, and 5, it's going to be. Now I see both of the number is not divisible by 2, then I'm going to divide by 3, but when I see the 5 is not divisible, it's obvious, and 125, 1 plus 2 plus 5, the sum of number of digit is 8, and it is not divisible by 3, so 125 is not divisible by 3, that's why I'm going to continue by 5. And when I divide by 5, I know that this is going to be equal to 25, and this is going to be equal to 1. And here we stop for 1 because we finished 160, we found all the factors of it, and we stop for it. We are going to continue with only 25, and I forgot to circle here because this 5 was dividing both of the number, that's why we must circle that one. And the result is going to be here, it's going to be equal to when you divide by 5, sorry, it's going to be 5, and if you divide again by 5, the result is going to be 1. But already operation finished because here the last number, when it is 1, it means that for this column the operation finished, so any number divides, it's going to divide only this side. That's why it's not going to be common factor. Okay, then we found at the second step, we are understanding that greatest common factor of 250 and 160 is going to be 2 times 5, which is equal to 10. So the distance between each tree must be 10 meters, because this is the greatest distance that is common factor for both of them. Greatest common factor for both of them. And we want to put least number of trees. Least number of trees, we need to put minimum trees. That's why the distances must be maximum or greatest. Greatest, and at the same time the distance must be a factor of the two number, 250 and 160. So we are going to find the greatest common factor of 260 and 250 and 160. So the distance between each tree is equal to 10 meters. And here at the second step, this is not the second step, sorry for that one. And the second step, we are going to find the perimeter of the field. We need to find the perimeter of the field, because when you find the perimeter of the field, you will find how many trees you need, how much trees you need. So perimeter of the field is equal to 2 times A plus B, it's going to be, which is equal to 2 times 160 plus 250, which is equal to 410, and 2 times 410, it's going to be equal to 820 meter is the perimeter of the field. Each 10 meter, if we are going to put one tree, it means that we need 820 over 10 trees for the 820 over 10 trees for the field, and when you divide them, we need 82 trees for the field. This is the second word problem about the least common multiple and greatest common factor. A recitation having promotion, and 12th caller gets free concert ticket, 15th caller gets limo, right? So which caller will get the both of them? So firstly, I want to explain who will get this free ticket. 12th caller, if it is getting the first ticket, the next ticket will be given for the free concert. It's going to be 24, and these numbers are multiple of, these are the multiple of 12, and second group is multiple of 15. It's going to be multiple of 15, it's going to be, because the 15th caller, then 30th caller, then it's going to continue like this. And we are going to find one multiple of 15 and 12, and this is going to be the smallest or least, and that's why the sentence is least and multiple. So we are going to find least common multiple of 15 and 12. So least common multiple of 15 and 12 is, you know how to do this operation. We are going to get the prime factors, and 2 divides only 12, 15, it's going to be same. Then when you divide by 2, 12, it's going to be 6. And if you continue to divide by 2 again, because 6 is still divisible by 2, this is going to be 15, and this is going to be, here it's going to be equal to 3, and when you divide by 3 this time, because none of them divisible by 2, so when you divide by 3, this is going to be equal to 5 and this is going to be equal to 1. We finished on this column and we are going to do only the operation here. 5 is the prime number, and when you divide by 5, the 5 it's going to be equal to 1. So the product of this number, it's going to give us the least common multiple of these two numbers, 15 and 12. So the answer is 2 times 2 times 3 times 5, and it's equal to 4 times 15, which is equal to 60, and 60th color it's going to get both of the ticket because it's the multiple of 12 and 15.